Here I will show you a program. The same program was in the previous video at the end, and in that a type of warning was there when I run that program. So first let us see that warning again, and here in this video we will try to remove that warning, and thereafter we will learn about queue data structure, this queues algorithm. First let us see that program. This was the program. I show you the entire program. This program was at the end of the previous video, and you see here, you see this was the entire program. And what was the problem with this program? The problem was very mild. However, that program was working, but there was a certain warning. I show you that warning again. You see, this was the output, but I have to show you the warning first. You see, this was the warning. You see, here, this was the warning. Warning, unknown escape sequence. And I explain why this warning was showing there. This warning happens when, because you see here I have taken a case. You see here this part, see this part. You see here I have taken a condition star first equals to null, but this condition is not true, because you see at the top, I show you, here is the declaration, and you should note that declaration does not consume a memory. Here from this part, when we observe the previous, which I have shown you in blue background, that part with this part, then from this part to that part, that is here, if you consider these two parts, and the second part is this, if you come from there to here, then in between there has been no malloc function. You know, malloc function creates the node, but from the earlier part to this part there is no malloc function in between, so no node is created. So there is no question of this condition null, because here we have no node corresponding to this first. So this is the reason here it shows a warning. So I have to remove this. I remove, here I have removed, but I have to add somewhere else, because it should work. That means if we go directly to option number 2, then it must show that first create a linked list. So you must see this part, this case part, this switch part. You see The problem is that the user may go directly to display part. This part is the display, and nothing will be displayed if you don't create the linked list. So we have to check whether this create linked list function has worked or not. For that, I have to take one variable here, and that variable will be under the name found, and its value will be 0. You know, for wrong statements in C we take 0, and for 2 we take 1. So here it is 0, and if it has created the linked list, then its value should be changed. This is the tricky one. So initially it was 0, it should be now 1, and here will be the second modification, because the user goes directly to option number 2. So here will be the condition if, and here will be not found. Then it should show a message, and here printf, and here the message. Here I take this thing below here, there will be a message, create the linked list first. Okay, first, and here semicolon to terminate, and here there will be exit 0. Now let us check the entire program. I go to run this program. Here I run. It shows something else, but this is due to an extra window. I have removed that window. Now I again run the program. Now this time you see there is no error, no warning. I show you. Look at this portion. You see error 0, warning 0. So our program is okay. Now I go to work in the output area. Here is the thing. I maximize the window, and here the problem was related to option number 2, and I press 2 without creating the linked list. I have gone for the option number 2, and I press the key enter, and you see this time it is showing the right thing, that is create the linked list first. So our problem has been solved. The problem was the warning. I have shown that there was no error, no warning, and the same output that we want. Create the linked list first. The user may think, the viewer may think whether this program will work in other options or not. I show you it will work. Here I have run the same program. Here I take option number 1, and you see this is working. 12, 89, 34. You may take any number of data, and to terminate the linked list, you know, we enter -1, and here I have entered 3 numbers, 12, 89, 34. Now I go for option number 2, that is display. 2, and you see the same numbers have been displayed here. So this program is working well in all the situation, whether you go for any option for the first time. You may go for the first time initially option number 1, thereafter 2, thereafter 3, or you go directly to option number 2. Okay, so the warning that was showing in the program of the last video at the end has been solved. Now we go to learn the queue data structure. What is queue? Let us see first. You know, if you go to certain places like cinema halls and there a person wants to buy a ticket, and you know, if there are a number of persons, then they form the coming person stands in a line and waits for his turn to get the ticket. That is the queue. And you should know that in the queue, deletion means when a person gets the ticket, he comes out from the line, and this is called deletion of the queue. This is called delete an element from the queue. And when a new person comes, then that person goes to the last point in the line, and the last point is called the rear point. And the first person which is in front of the ticket distributor, that person is called the front. So for the queue we will remember these two variables, front and rear. And also you must keep in your mind that deletion means when the front person gets the ticket, he comes out. This process is called deletion. Insertion means the new person comes and stands at the end of the line. This is called insertion. So in queue data structure we perform deletion and insertion, and here there are many ways to perform these two, insertion and deletion, but here in here we will perform queue data structure using linked list. So I have already explained the linked list data structure, and I again remind you the same thing. In the linked list data structure, you know, there are two parts. Here I show. This whole thing is called a node. This is a node. These two parts together is called a node. This is called a node, and the first part is the data part. And the second part is a pointer part. You may say it link part, you may say it next part. I say it linked part, but in the previous video I have addressed this part as a next part. Here is the link part. Due to this part, the various nodes are attached. Various nodes get attached, and I have already explained that attachment. I remind you the same thing. Suppose this is node 1. That is, this is the first person in the queue, and obviously the second person will come. So for that person I have to create one more node. This is the node number 2. Okay, I type here, this is node number 2, and this node is for the second person, and obviously this part will have the same, that is two parts. The first one is the data part, and the second one is the link part. And in the earlier video I again say that I have used next part. Next, this part belongs to the pointer part. Now you see there are two nodes, and these two nodes are at a separation, but in a line, in a queue, the persons will be attached, should be attached. And how we attach? If you understand these two parts, then you can understand for many persons. If you understand the attaching mechanism, then you can attach in the same way many persons. So I show you how did we attach. I have already shown in the algorithm of the linked list, but I show the same thing again. And for that, I have mentioned there that for that we here we take a gum, gum. Gum is used to attach two things. Here I take layers of gum. You see, here is the gum. Okay, I have pasted the gum, green gum, and you see the next thing. Next thing, we take the data part of the second person. This node belongs to second person, and node has two parts. We take link part of the first person, and we take the data part of the second person, and thereafter we paste, thereafter we keep this pink part over the green part. If you do so, and here you see in both I have typed data, but to differentiate, because there are two persons, so I have to differentiate, and for that, to create a difference, I take here in the first data 1 and in the second data 2. And now if you keep the pink part over the green part, then the resulting structure will be like this. I show you. If you paste, then here will be data 1, and here data 2 comes. Here data 2 comes, and here link part comes at this place, and this link part is, remember, this link part is of this link, and you see that now data 1, data 2 both have come closer. This is the cause of generating a queue using the linked list, and a third person goes, then in that case here will be the data 3, and beyond that at this place there will be link. So in that case will be data 1, data 2, and here data 3. So in this way you many persons can be attached. Okay, so this attachment, due to this attachment a line will be created, and in the queue data structure, as I mentioned earlier, that there are two operations, deletion and the insertion, and insertion is the same. You see, I have attached the second person, the second node here with the first node. This is called attachment. This attachment is called insertion. Same thing, insertion and creation. Both have the almost similar meaning, but in creation you attach many persons, but in insertion we attach only one person, that is only one node at the end. And now the second part, second thing is, second operation in the queue data structure is the deletion part. You know, when a person gets ticket, then he will come out from the line, and deletion means we have to remove the first node, we have to remove the front person. For that we have to remove this data 1. And how can we remove? If you have understood the attaching mechanism, then this deletion is just opposite of that. And for that, you see, I have kept the pink part over the green part. So for the deletion we have to remove this data 1, and for removing this, the link part of this node, you see, the link part of this node is below the data 2, and for that we type, for the deletion we type, I show you, we type link part of, here we, for the deletion we do link part of 1, because I have to delete the first person, the first data. This made to null, this is made to null. If you do so, then our deletion is complete, and doing so enables us to delete the data 1. When you delete the data 1, remember the data 2, that is the person, second person will be the first person, second person will be the front person, second person will come out in front of the ticket distributor, and that person will be the first person. So in that case the front will now indicate the data 2, because data 1, that is the first person, has gone. Okay, this is the mechanism of the queue data structure. In the same way, suppose data 4 is the end. So the rear rear will indicate data 4, but when you insert one more person, that is data 5 will come, then in that case the rear will change. Earlier the rear was 4, now the rear will be 5. These things are very easy to understand. You can understand these things. Okay, so then in this video we learned about the queue data structure. We learned how to create a queue. We learned how to delete an element from the queue. We learned how to insert an element in the queue. Okay, thanks. In the next video we will type a program for the queue and will perform these two operations, delete and insertion. Okay, thanks.